Hello everyone. Today we'll cover the AWS training and certification for the cloud practitioner. So this is the guide that is provided by AWS. So I'm going to go through the guides that they provide, the PDF, and then I'll go through a few questions that we'll answer today, and then we'll finish with some tidbits for how do you pass the exam. For finishing the cloud practitioner certification, which is the most fundamental certification that AWS offers, this covers, like according to the exam guide, this what you need to learn during that is we understand what the AWS Cloud is. You should be able to define what it is and its basic global infrastructure. You should be able to describe the basic AWS Cloud architectural principles. You should be able to describe the AWS Cloud value proposition, that is, how much cloud has value over your own on-prem servers. Sometimes there may be a case where your on-prem makes more sense, but in most cases, AWS Cloud has a better value. So how do you describe that value proposition? What are the key services that they offer, and the common use cases that we use on AWS, such as hosting a website, hosting a like application that one of your company uses, those kind of things. We have to understand basic security and compliance aspects. This shared security model is one of the most important things they talk about, where a part of the security is owned by AWS, which is kind of the bare bones servers, the buildings that the servers are on, or anything that is relevant with the physical infrastructure, and anything that the application that you install on the AWS infrastructure is owned by the customer or the person who's actually using AWS services. So that would be a very important topic there. Some topic that's a little difficult for me, I've been struggling through, is billing and account management and pricing models. It's not that this part of the certification is difficult, but it's more not something I've really worked on too much. But that is part of the certification. The second last thing we need to understand is, where will you go to find documentation or technical assistance if you need to look for something? And then you'll have to, the last thing is, would you be able to like describe the characteristics of deploying and operating on the cloud? So those are what they go through. They've provided some white papers that they provided. They provided some sample questions as well. We'll go through those. In all these links, we'll go through in the next session. There are also some quiz shows that they've provided. These go through some questions and answers, which I will cover few of good questions today as well, which kind of gives us a good understanding. In the guide that they've provided, this is what they mean by each of these concepts. So they've provided what do you mean by defining the AWS value proposition, and so on. Within security, I think we spoke about the shared responsibility model. So a little bit more about that is AWS is responsible of the cloud, that is any data center, physical security, hardware networking, but customers actually responsible for everything that goes in the cloud. So off the cloud, in the cloud is how they term it. So in case you see something where the off in terminology is being used in the exam, so you remember that in the cloud is responsible by the customer and off the cloud is responsible by AWS. The next thing about security is to understand the IAM terms, providing least privilege access, that is providing the bare minimum access that any person would need. How does AWS use encryption at rest? That is when it's stored somewhere, in a hard in a EBS or a EFS or an S3, it's encrypted. It is encrypted when it's just stored there. So even if somebody has to read it, they need to decrypt it. Not only that, during transit, when it's sent through the internet, uh, when an API calls it, or when somebody's looking for it on a website, or an application is looking for it through an API call, how does it during transit as well? It's encrypted. So understanding all those concepts, understanding the groups, roles, and users. That is identity and access management terminology, and then like security support. They want us to at least understand the terms that are cloud trail, guard duty, shield, um, trusted advisor. Within technology, they want us to understand what the console does, which is where you log in to the website and you're able to set a lot of things. And there's also a command line interface where you can do most of everything that the console can done much faster, but you have to know the commands for it. There is an SDK which you can download and you can use, and they have it for Python, for Java, for JavaScript, most other typically used programming languages. Cloud formation, that's something we need to understand, learn for this exam. We need to understand how the global infrastructure of AWS is laid out in multiple regions, and within each region, multiple availability zones. How are they set up? And what are edge locations? That is when you have to deliver content in multiple regions in the world, say one in North America, one in Asia Pacific. How do you like cache the copies of those on different edge locations so that users use it much faster? These are relevant for any organization that has worldwide operations, and especially they have a lot of content that needs to go through the internet. For example, Netflix, Route 53, which is a like it's a domain name service, so it identifies what IP address your actual website would point to. So those services provided by AWS, you need to understand. You need to understand the core aspects that AWS provides, which is like compute, which is they provide a computer online. Especially the most important one that comes up is EC2. And within EC2, you need to understand how do you auto scale, that is, increase the amount of computing you need as the need for computing goes up. And what is an Amazon machine image that actually allows you to quickly have a template for building that EC2 instance. What is an elastic beanstalk? You need to understand that. What is a ECS, a container service? EKS, which is very relevant to ECS. So you would know, probably you can learn those two together. The Lambda service, which we use a lot in my organization, like where you use computing without actually provisioning any EC2 instances or any servers. You just directly implement the Lambda function, just write the code for it. Don't even have to worry about how much computing you need. So that is serverless. And we checked computing in technology. The next most important thing is storage. So S3, most of you have heard of it. This is where you have object storage, whatever kind of storage you want to have, that is mostly static. It doesn't change often. Say you have photos of a lot of things that your customer capture, and that gets stored on your server. So all those things would typically go towards a S3 bucket. And within S3, if you want to store for a long time and you don't really care about retrieving it all very quickly, you could store it in a Glacier. So S3 Glacier, you need to understand that. The Elastic Block Store, this is goes in hand with the EC2 instance, where an EC2 instance, when it shuts down, it may lose all its storage. And when you when you start another EC2 instance from another AMI, Amazon Machine Image, you might not have the same storage link to it. But if you want to store it for longer times, then you would need a EBS that goes along with your EC2 instance. Another thing that goes along typically with EC2 instances is the EFS, which is a file system. Here, these file systems like can be accessed by multiple EC2 instances, not just one EC2 instance. And like recently, not only from EC2 instance, you can also like access EFS from Lambda functions. But you need some computing to go with it for the EFS. A storage gateway. This is like hybrid storage, cloud storage. This gives you on-premise virtually unlimited storage. And database services like RDS, DynamoDB, AuroraDB, Neptune, Elasticache. And I think RDS and DynamoDB are the most asked questions that come from that. With respect to networking, what is a virtual private cloud? How do you provision it? What are the like differences between a VPN and a VPC? What is direct connect? What is elastic load balancing? When you use multiple availability zones to load balance your like if you get multiple API calls, how do you use ELB to send some of the API calls to one availability zone versus another set of API calls to another availability zone? That is something you learn when you understand elastic load balancing. What are security groups? That is something else you need to understand. Network access control list, database migration services, server migration services, Cloud Trail, Cloud Watch. You need to understand trusted advisor, systems manager. The last thing in technology is you need to go for AWS support models, basic model, developer model, business model, and enterprise model. So this is where like when you have something implemented in AWS, you would need support from AWS to actually help you with that. So these are the different tiers that you could ask for. Each comes with a different cost. Obviously, the basic is the least, and the enterprise is the highest cost. But it also comes with that level of support. The next domain you need to understand is billing and pricing. So billing and pricing, we need to compare and contrast the various pricing models. S3 pricing, we have like the standard and the intelligent tiering, which AWS determines based on how many times this file is accessed, how long this file has been there. It intelligently tiers it from standard to another one or to another one. So S3 is intelligent tiering is essentially something that automatically AWS helps us manage the cost. If you want to determine some things don't need a standard, you rarely access it, you put that in infrequent access. And if you want to infrequently access it, but you only do it from one zone, that is most people who access this data access it from one particular office or one particular location, then you would choose the closest zone and then use that zone as your one zone infrequent access. In this case, you store it in one availability zone. It's not stored across multiple regions or multiple availability zones. So in case one availability zone is gone due to disaster, then we would, or if servers are down, network is down, you would not be able to access that data. The Glacier and Glacier Deep Archive are much cheaper versions of storing these. These are typically for data that is very rarely retrieved. Typically, what our use cases are, I used to work in a bank, so the bank used to archive its data uh, so that it stores it for longer term. The data that is needed by the Fed or for a regulation that you need to store for 3 years or 7 years, but it is typically not accessed. But because the regulation wants the bank to store this data for 7 years or 5 years, depending on the data type, the bank stores it in S3 Glacier or in S3 Glacier Deep Archive. Then, with respect to the pricing, we need to understand the requests and data retrievals. How do you, how frequently do you request it? How frequently do you retrieve the data? And based on that, we can understand how we need to use this. We need to understand how much the data, how you would transfer the data from your location into AWS, and data transferred in from the internet. That is one option. It is probably the fastest for large amount of data. Um, so when data is transferred between S3 buckets in the same region, when the data is transferred from an S3 bucket in one region, um, or if it's transferred out to CloudFront. So those are different data transfer options we have. So we also have to understand about pricing of EC2. That is, how do we opt for EC2? The typical way we do it is we do it on demand. That is, we request for EC2 and then we can keep it for however long we want. And then when we don't want it, we just close that and then we stop using it. As we stop using it, we're not charged for it anymore. Uh, that is the typical way it's on demand. Uh, and when you when you believe that now I don't need it, you stop using it and you'll stop being charged at that point of time. Obviously, there's a minimum of 60 seconds. So if you stop like within few seconds, you will still be charged for the whole 60 seconds. But if you stop it after like 233 seconds, you will be charged for 233 seconds. So there's a per second billing for this. The next thing is when you know that you would need this instance for a year or 3 years or 5 years, then we can actually reserve the instance, and that would help like offset your costs. And as AWS puts it, there can be up to a 72% discount on reserved instances. The problem with reserved instances, you pay for the whole 3 years. So if you don't use it, then you don't. You still have to pay for it, but it comes as a much lower rate. So if you know that you're going to use a particular type of instance, then you can definitely pay for it. There is also another case where you can get spot instances. Spot instances are types where you don't know. You don't have a dependency on the instance running at a particular time. So in that case, you can get the spot instance for a 90% discount. Say for example, there's a batch that runs for 30 minutes and it runs every day, but it doesn't have to run a particular time of the day every day. So and it can be restarted easily. So that's when you choose a spot instance. The spot instance helps offset the cost, and that helps go through with much lower cost. A dedicated host helps with physical servers. With Amazon EC2 instance, that's fully dedicated for your use. So you get it's like getting your own server, but Amazon manages the actual server. So this is typical to what a company gets an on-prem server, but in this case, it's dedicated to you, and it's actually managed by AWS. The next part of pricing is to understand Lambda pricing. Lambda, as we know, is a serverless computing. We pay only for what we use. We don't really allocate EC2 instances. We just write code for it, and whenever the Lambda function is executed, we have to pay for the computing power that it uses. And if a particular week there are no Lambda requests, we'll pay nothing for it. And if another week there are like a million requests, you pay for that week. That's how that's how it goes. There's also an understanding we need to have of the free tier. The free tier has certain services that are provided always free. For instance, Amazon DynamoDB, you get 25 GB of storage free free storage per month, and that is available throughout. AWS Lambda allows 1 million free requests and up to 3.2 million of compute time per month. So you could write an Amazon AWS Lambda function, implement it. People can call your Lambda function, get back results, and if you're doing 1 million per month, then you still don't have to pay any money at all. Some of them allow you to try it for 12 months. For instance, the S3 standard storage, you could use it for a year for free. You could also use Amazon CloudFront data transfer out. And you want to set up a computing instance in EC2, then there are some thresholds where you can get a limited amount of compute time per month free of cost. There are also trials that happen. For example, we get a 90-day free trial for certain services. This example is Amazon Inspector, but there are also other things that come up and are available in various periods as AWS changes their policies. So we need to understand many tools that AWS provides for billing support. The Cost Explorer is one of the most asked questions. They ask about how to use Cost Explorer to understand how much cost it's going to impact you based on adding services or removing services. So you can do all that analysis using the Cost Explorer. The TCO calculator helps understand how you will pay based on choosing different models. Like when you choose reserved instances versus you choose on spot instances versus you just go on the go. So how does that differ, right? So all those things can be done using the TCO calculator. The AWS pricing calculator helps understand how each service would cost depending on how much you're going to allocate to that, how much RAM you're going to allocate to a EC2 instance, how much data storage you're going to allocate. So based on that, you can understand this service is going to cost you so much. AWS budgets is another thing that is apart from Cost Explorer, AWS budgets is one thing they ask a lot of questions about in this certification exam. So it allows you to set custom budgets, and whenever you cross that budget, then you get an alert. This we have set up for all our clients in the company I work in, and this is very useful for the clients because they're able to see that okay, this month we are crossing the limit or they're not. So that's very good for the clients. Tags, again, this is one thing we might see a few questions on. So tags allow you to tag things such as cost center, application name, customer name, project. So you can put in everything as a tag, and when you tag your EC2 instance to a tag, so we know that all these EC2 instances fall under this application or this business unit. When you tag different VPCs to a tag, these VPCs fall under this tag. So that tag is very helpful to understand and split your cost based on different things. So they don't. You can use tags in any which way you want. So it gives you a lot of flexibility. You can typically do it based on cost center or business unit. If you're doing one AWS Cloud for multiple customers, then you can do customer name based on it. So those things are very, very flexible, and you can do it the way you need it. So this is the Cloud Practitioner exam guide provided by Amazon. Next, we'll go through some of the questions that are relevant for today's exam, and I'll go through the next 35 minutes going through that here. So this is a good start. So today we'll go through the Cloud Practitioner exam. There are 4 major topics we have to cover in this. One is the cloud concepts, security and compliance, technology, and billing and pricing. So these 4 are the topics we'll cover today. Before we go in, an introduction about myself. I am Anand, and I've mainly worked on data-related technical programs. I have over 16 years of experience, worked mainly in data management, data analytics, data flow, data pipelines, data automation, and data science. I don't have a AWS Cloud Practitioner certification yet, but I'm registered to take it this month, October 2021. And I do have a Google Cloud Professional Cloud Architect certification, which is helping me study for AWS Cloud, where I relate to these AWS services with what Google Services has. So let's go through some of the questions. The first question we want to cover today is which cloud architecture design principle is enabled by availability zones. So for this, we need to understand 2 parts of the question. One is the cloud architecture design principles. So we need to understand the design principles, and they're asking what of the principle is enabled by availability zones. So we need to understand the term availability zones as well. But I'll go through those one by one and break through all these options that we have here as well. The options given here are disposable resources instead of fixed service. And second one is removing single points of failure. Third one is Amazon EC2 and loose coupling. So if you've heard of the word Amazon EC2, I think we can understand that that is probably not a design principle, and they're asking for design principles. What if you don't know what EC2 is? So EC2 is a virtual server that you can use to run applications on AWS. What it provides scalable computing capacity in the AWS cloud. When you set up an EC2 instance, you can custom configure the CPU, storage, memory, and networking resources. EC2 instance is a remote computer. You run Windows or Linux, but you can just log in from your computer into a remote computer that is sitting somewhere else, and you can install whatever software you want on that. You can run like a database server and PHP code that would actually show up as a website on everybody's like when somebody wants to browse a website, you can host it on that virtual server, or you can just use a storage service such as S3, where you can store photos or video files, and you can share those with other people, and then they can access that through the web, through a web browser. That is what an EC2 instance is, which is not really a design principle, so we have eliminated one of them. If you remember the question, another thing we can easily remove off is disposable resources instead of fixed service. So what does that mean? So when you have fixed servers, you have a limited amount of computing capacity. You can't really scale it. and you can't scale it up. At the same time, you can't scale it down. But when you actually have disposable resources, you can actually dispose of the resources when you stop using them. So for instance, you've seen EC2 instances that are part of an auto scaling groups. So in that instance, when you have a EC2 instance, you build it up, and then when you don't want it, you just dispose of it. But in an auto scaling group, all this is done automatically. The auto scaling group has rules about creating and destroying existing instances. So if there is one EC2 instance running and suddenly the traffic increases and there are so many people browsing your uh, website, and that means you need two EC2 instances to cover for the traffic. So your auto scaling group can scale your EC2 instances to 2, so it can increase the capacity. And when people stop visiting a website because it's late at night, or it's because the demand for that particular thing has gone down, so you can actually scale it down and you can dispose of these resources. So that is what um, this can help with. But an availability zone is what the question is. Um, Availability zone doesn't actually dispose of your resources. That is a different concept. So disposing of resources instead of fixed servers is a cloud concept that we use, but it has nothing to do, and it is a very good design principle, but it has nothing to do with availability zones. So we can strike that off. Another example of disposable resources is the Lambda function. So Lambda function, we don't use any computing resources until somebody calls that particular function. Say if 10 times the function is called, um, we use computing resources, and then when somebody stops calling it, we are not using the computing resources, and AWS doesn't charge us for that. So in this case, again, we used up some computing resources when some people are calling the function, and when people stop calling the function, we dispose of that particular computing resource. A, a container is another place where we have disposable resources. A container is an immutable application image that we launch a whole application, and then when we don't need the application, we can actually stop the application and then stop using it anymore. So these are examples where we do use disposable resources, and it is a very good design principle, but it's not relevant to our question of uh, availability. So the next thing we're going to look at is loose coupling. So loose coupling is another thing we can strike off. The reason is loose coupling is when one element of your application changes or has an issue, then the rest of the application should still be able to work. So when you have a monolithic application architecture, like in the left, we see that the presentation layer could be able to call, like the orange presentation layer could be able to call the green one or the blue one, and the database layer is in one place. So if if there is a problem in the database layer in the NoSQL database, that hits any part of the application. So multiple applications could be impacted. Rather, when you modularize it and have each service as a microservice, so in the case of the left architecture, we have a monolithic application. We split it into smaller microservices, and we have multiple microservices. So each microservice is only dependent upon itself. So if the database in this orange application fails, only this microservices fails. Application users can still access this green application and the blue application. So they're not worried, or they're not stopping their work because one part of the application does not work. They probably cannot do certain things, but they can still do other things with the application. So that's what loose coupling is, and that has nothing to do with availability zones, because availability zones is a different concept which we'll cover next. So that's something we strike off as well. So this is another design concept which is really important in cloud, loose coupling, but it's not relevant for our question. So we come to the answer now. So it's more of the answer would be removing single points of failure. And why would we say that removing single points of failure is more related to the concept of availability zones? So let's understand what availability zones are. So availability zones are essentially within a region, places where you can have highly available applications. That is, when an end user gets through the network and access your application is available in two different availability zones, and which is actually a discrete data center. So this particular availability zone says is in a city A, and this is in a different city B, and this data center has like different power networks, different connectivity, different services than this. So even if there's a power outage here, which is say company A is your power company and company C is your networking provider, here your company Z and Y are your power provider and network provider. So even if this company C goes down, because the company Y and Z are still up, this availability zone is still up. So in this city, this availability zone is present, and in another city, this availability zone is present. They have discrete data centers. So even if your end user tries to get some information, and because this is failing, they can still request again and go through another availability center, and using elastic load balancing, we'll automatically route to the center that's not erroring out, and we'll be getting the result back. So that is the use of the availability zone. In this case, if you see, it's fault tolerant. So if you have a fault, we still tolerate it, and then we go through to the right availability zone where there are no faults, and we are still able to provide the user with whatever information they're looking for. So that's why it's more related to the fault tolerance than any other design principle. So these are the 9 design principles for clouds that we'll have to understand and talk about. Um, Obviously, as you go to scale, like cloud, you're able to scale up or scale down. What happens if demand increases? You can scale up. If it does not increase, you can just stay there, because you don't have to. If it's a server, you'll probably have to provision, assuming there are a million users, and then you build servers for million users, but you only have 1,000 users every month. In that case, you're not paying for a million user server capacity. You're just paying for how much you need. So you can actually scale up or scale down with cloud. Another thing that cloud can do is, another design principle is, you can automate your environment. So if you want to test something and then deploy it somewhere, you can build a CI/CD environment where the tests can be enabled there, and then after the tests are successful, it goes and deploys somewhere. You can have a human do it, but every time the human has to do the same thing, that is where we can actually ask a computer to do it. So cloud is somewhere where you can automate your environment completely. You can also use disposable resources. So whenever something is not working, whenever something is not needed anymore, you actually want to just throw it away and use a completely build something new. Cloud is the place where you go, because you can always stop using that, just go to a completely new infrastructure and build a new application, which would be much more difficult when you have an on-prem, where you'll either have to sell your server out, or they completely uninstall everything on your server, like go back and install everything and then do everything again. The next design principle is loosely couple your components. In this case, when one application has an issue, the rest of the application should still work. I think we saw this loose coupling in one of our slides. Design services, not servers. So in this case, we want our company to work more on designing and building an application that is the actual functionality the company wants to do. They don't want us to have servers set up and maintaining the server, putting in a patch for the server. So all that need not be done. The next thing is next thing we want to do is understand your single points of failure. Understand which points of failure. There are always some points which will fail, and certain points, if you fail, you cannot do anything at all going forward. Say for example, the website of Facebook was down this week. So the problem was the Facebook domain name server was not able to get people to Facebook when they typed in facebook.com. In that case, that's a single point of failure, because after that, you're not able to do anything, because you're not even able to get to Facebook to actually do something after that. So that you have to understand what your application's single point of failures are, and then as much as you try to avoid it and eliminate it, that helps the application perform much better. The next thing you have to do is optimize for cost, and cloud helps optimize for cost much better. So you can understand how much your cost is, optimize for it, and then work accordingly. You can secure your infrastructure at every layer. So you can make sure your infrastructure is secure. You can use caching. Caching helps retrieve something much faster than hitting a database every time. So caching is used for most time where people do it the same thing multiple times. So in that case, if your data is cached, that relevant data can be inquired much faster. The next question we'll cover is which AWS service allows content to be accessed via web browser. So let's dive deep into this in the next streaming session. Thank you so much for watching. Have a good day. Bye.